So on our first problem, I gave the kids a group and I said to take that red problem and to solve it. And then I helped a little bit and said that secant is 1 over cosine and cotangent is cosine over sine. And then there's still a sine here. I'm just going to bring it straight down. Try to get it together in your head how that actually turns into tangent squared. Okay. I'm going to just show you that this one that I'm putting in black parentheses is the same as this right here. And I'm just bringing the sine theta down. And now I've got this over 1. So then the sine squared on the top and cosine squared on the bottom. And what is sine squared over cosine squared? And if you did this, I would have to cry a little bit, and at the best I could give you is 5% off for being close. Why can't I just leave it that way? Because you have to finish this and turn it into tangent squared equals tangent squared. I'm that picky. Because why? Because I have to be, because it's a proof and you got to follow certain rules. If you had changed tangent into something else along the way, also, if you had worked on the right side, I wouldn't be able to give it to you. You can look at what it would turn into. Like if you could play with this and go, well, that could be 1 minus secant squared, but that wouldn't really help us here. So, all right. Now let's try numero 2. Dos. It's sine theta, and I was kind of distressed at how many kids just were completely lost on this one. Sine theta minus sine theta times cosine squared theta. And all of that equals sine to the third. All right. So there's kind of a trick to it. Once you see it, you can't unsee it. And you'll be like, oh my gosh, it's easy. Has anybody caught it yet? Yes? Okay. That's true, but it's not really the way to do it. All right. So, do you get in the middle of a test? I want you to be thinking just like this. Oh my gosh, I'm stuck. Just like the whole room of really smart kids are stuck. Then the answer's right here every time. If you can factor it, you should. All the smart kids are stuck. It's factoring because nobody sees it. Do you see it now?
Yeah.
Ah, somebody sees it now. You can factor. What can you factor out? There's a cosine squared in both parts? No, there isn't. What's in common in both parts? Sine can be factored out. Factor it. Because if you can factor it, you should. I know, for a lot of kids, this is still hard to factor, but you got to be able to do this. You got to notice, there's a sine in both of them. That's a common factor. I will factor it out. And I think the part where you get stuck is like you're not sure what to put in here. Well, obviously there has to be a minus because there was a minus in the problem, right? And it's not that hard to figure out, but I'll give you this little hint. If you're dividing by if you're factoring out a sine theta, then you're really dividing this by sine theta and this by sine theta. And then you see what you get when you divide by those. So then what's sine theta divided by sine theta? 1. And what happens to these? Well, these cancel. So you'll have cosine squared theta. And then what's 1 minus cosine squared? Don't you recognize that?
Sine squared.
Oh my gosh, see how easy it is? As soon as you get it factored, it's like a slam dunk from there. I bet you there'll be a lot of kids stuck on the test tomorrow. I hope that you kick in and go, oh my gosh, I'm stuck. I wonder if you can factor it. Yes, sir.
Why don't you, involve the...
Wait. If you're going to say, is there another way to do it? There absolutely is another way to do it. And if you have another way that you show all your work right, that'll be totally cool. But I don't want to go into it right now because I really want to lean into the factoring. If you don't get why it factored, that would be much scarier. I know, there's another way to do it. And it would have been not easier. Not at all easier. Because as soon as you see there's a sign here and a sign here, you can pop it out to the front. And then 1 minus cosine is just such an easy one. You're supposed to see that one in your sleep. 1 minus cosine, oh, that's sine squared. And so then this is sine squared and this is sine. And as always in my class, I encourage you, if you have another way to do it, cool. You just got to show how you did it. What's not okay is to just go, well, I got the answer. I just couldn't explain how I got it. Well, then you aren't going to get any credit for it. Sine to the third equals, bring this down, sine to the third. Okay, so that was our second one. What was the key? Factoring. Okay, third one. Third one is up here, and it's sine of alpha minus beta, and right away, you should know where to look. Where do you look to get some help for this? Nobody in here has got this memorized, I don't think.
The difference identities?
Yeah, sum and difference identities. And this one's an add. So you're going to go look that up. I'm going to hand a sheet to everybody, but you need to know more about alpha and beta. So here's what I'll tell you. Sine of alpha is negative 1 over 3. Did I just give you two sides, the opposite and the hypotenuse? But you got to know where to draw it. I'll tell you, it's in quadrant 3. And the second thing I'll tell you, which will allow you to draw another triangle, is that cosine of beta is negative root 2 over 3. And that's in quadrant 2. Now, this will need to come off the sheet. I'm going to hand those out on paper. You have a digital version if you're doing this at home today. You have a digital one that's in the Schoology folder for today. Pull that up. You need it for this test. You need it to even practice for this test. Okay, I got the setup kind of like most of the way done. Owen, can you tell me in that first drawing where you have the 1 and the 3, what's the third side?
That's going to be a negative square root of 8.
Negative square root of 8. I would agree, except the square root of 8 would cost you something on the test because you should have simplified it.
Oh, 2 square root of 4. Or square root of 2 root, right?
2 root 2. Because square root of 8 is not simplified. Asher, that other triangle, the 3 and the root 2, it's the square root of something.
It's the square root of 7. Oh, wait. It is
9. 3 squared is 9. Square root of 2 squared is 2. So you were right in the first place. It was 9. Wait a minute, something's wrong.
I think the 3 is the add.
Oh, I put the 3 in the wrong spot. Thank you.
It would still be square root of 7.
And it is the square root of 7, but that's probably what froze you up as you looked up at the screen and I had the 3 in the wrong spot. Square root of 7, because it's 9 minus the 2. That gives you square root of 7. And the reason it's 2 is because you go the square root of 2 squared, which is 2. So 9 minus 2 is 7. There we go. Now that you have all that, you should be able to finish this part. I hope this part is very doable. Remember, you'll always have a common denominator. How many groups are absolutely done? Okay. Remember, go work on the worksheet for a little bit then, because you have a worksheet that's not tiny. Decent sized worksheet. You might want to work together on that.
Wait, no, I did this. This one. All the bases 3.
Yeah. Sine of beta is
All right, so here's our alpha drawing, and here's our beta drawing, because, you know. Now, sine of the alpha one is opposite over hypotenuse, and that seems familiar. Oh, look at that. It tells us sine right there. Sine of the alpha is -1 over 3. Cosine of the beta, that's this drawing. Cosine of beta, cosine within this triangle, -√2 over 3. Cosine of the alpha one, that's this triangle. Cosine's adjacent over hypotenuse, -2√2 over 3. And last but not least, sine in the beta triangle, which is this triangle again. Sine is opposite over hypotenuse, √7 over 3. Now look quick at the denominators, because Mr. Cervero has said they'd have a common denominator. Do they? Yeah, so then I did it right. Not a guarantee, but at least you know you have a chance. So then the denominator's 9. What's the top? Make sure you and your partner agree on what your answer is, and I'll call on one group in a second. Okay, Jaden Hahn, we're doing the top part here. Can you tell me what I get for this? A little louder. √2 is correct. And then I have a plus, but then there is a minus, so it's minus. Oh, I like it. That is correct. If you left your two roots multiplied next to each other, like √7, √2, close, but no. There's a minus on this 2 right here. Okay, don't feel bad. I forgot the negative right on that side too. Right here, there's a negative. So that's why it's negative. All right, so that was a tough one. You got so many little things to do, and half of your question was chapter 12. The last chapter had things like this in it. That's why I said it was so important. It keeps coming back. Circle trig. Okay, next we're going to go on to the fourth question. This one's just to remind you about common denominators. 1 over 1 minus secant. If I tell you that your answer needs to come out with cosines in it like this, you'll know, well, duh, I need to somehow get cosines into my problem. How do you get cosines into the problem? Well, you replace secant with what? Yeah, secant is 1 over cosine, so this shouldn't be that bad if you understand how to do common denominators, but some groups will and some groups won't. So you know that this turns into 1 over cosine. Can you take it from there? You'll need a common denominator. Pausing while you answer question 4. By now, if you understood common denominators, you'd be done. So let's see. 1 over 1 minus 1 over cosine. This 1 right here can be turned into cosine over cosine. Now they have a common denominator, so now they can go together. Cosine of theta minus 1 over cosine of theta. But what about the 1 on top? I need to bring that down, and it's still 1 over all that. But what does 1 over something mean? Just flip it. So then it's cosine theta over cosine theta minus 1. The top became the bottom, and the bottom became the top. And now that looks frighteningly similar to that. So yay. I proved it. Any parts of that you don't understand? Okay, last one that I want to do with you, and then again, if you finish these early, go work on the worksheet because it's due tomorrow, and it'll help you a lot. So tangent of some angle is -1/5. I can't draw it yet because I don't know which of the two quadrants it's in, because tangent's negative in two places. But then it says sine of the angle is less than 0. That implies sine is negative. And that's true. So I know sine is negative, so then I know I have to be in a certain quadrant. Draw the picture of that, and you'll have a nice little triangle with 3 sides. Given 2, you'll find the third. And then at the end of this problem, they hit you with sine of 2 theta. There's 2 kinds of kids. Kids that have it memorized and kids that don't. The kids that have it memorized have an advantage because they don't have to look it up on the sheet. And they're going to do better on the ACT test. And they're going to do better on the calculus AP test, because this one could come up. And it was 2 sine cosine. But if you're one of the kids that doesn't have it memorized yet, fine. As long as you can find it. And then apparently I need to know sine and cosine. Where am I going to get those? From the triangle that you draw. All right, so go ahead and finish this one off. It's actually an extremely easy one. I'll pause while you finish it. Okay, so the final answer for this one. First off, I got to draw it in the right quadrant. All students take calc. So then sine is negative, so then it can't be here and it can't be here. Tangent is negative, so it can't be here. So that means it must be here. And then tangent is TOA, opposite, over hypotenuse. And I just did it wrong. -1 is there. Okay, and then 1, 5, and the square root of, let me think, 25 and 1, but it's minus, so that it would be 24. Now, does 24 simplify down? Uh-oh, 25.
It's opposite over adjacent.
Oh, thank you. There is a 24 involved somewhere, but hold on. Okay, so, hold on. So, TOA, opposite over adjacent. This one's 5, and this one's -1. And I kind of drew it funny, so I'm going to make it more proportional. There, okay, now, tangent, opposite, adjacent. Okay, this one's negative, and that's all good. Okay, so then we go square root of, and 25 and 1, and this time you add them, so it's 26. Okay, so there, square root of 26. Now, sine of this, to get this part, I need sine of theta. So sine is opposite over hypotenuse, and that one was -1 over root 26. Cosine is 5 over root 26. Final answer, -10 over 26 simplifies down to -5 over 13. Have a great day. Be ready for that test tomorrow. There's a couple of great things in your worksheets that you could do for practice. Take care.